All right, we're back. This is still page 13 of notes 2 of math analysis. It's really page 13 of math analysis. It's in notes 2. Anyway, we're using right triangle trig to try to solve some interesting problems. And this is one of my favorites. This is I think it's one of the coolest applications of trig. You can do these indirect measurements and they're very cool. So let's see what this says. Surveyor stands at some unknown distance from a tall, inaccessible hill and measures the angle of elevation from her position to the top to be 53 degrees. So this, at point A, I guess, is where she starts. And then what does she do? Then she walks back 400 feet in a straight line and remeasures the angle, finding that it is now 27 degrees. So like think about that in life, right? Like if you're standing really close to something and you look up, you look way up. Then you back up a lot and you look up and you tilt less. So it makes sense that you get a smaller angle there. So this so far makes sense to me. And then the problem just says calculate the height of the hill. All right, so in the notes here, it says there are at least 2 different ways to solve this. It's nice if you understand both, like you should. One of them, however, involves the law of sines right now. We don't need to know that right now. So I'm gonna first do it this way, then I'll maybe decide if I wanna do it the other way. I don't really know. Also, your calculator can just do it. So we're gonna also do it that way. So let's see if we can kind of set something up here. So, all right. Vertical distances I usually call y if I can. So I'm gonna do that. So that's gonna be y. And then there's a distance we don't know, right? The distance we don't know is the inaccessible part, right? So it's the distance from A to B. I don't know it, so I'm gonna call it x because it's horizontal. Now, what do we get out of this? Well, if I focus in on 53 degrees, I actually do know, well, I don't know it, but I have kind of named the opposite and the adjacent. So I could say the tangent of 53. So the tangent of 53 degrees is y over x. I don't know, probably a good start. That's one equation and 2 unknowns. So if I can find another equation using the same unknowns, I could potentially solve that system. So let's look for that. Well, there's another angle, so 27 degrees. Opposite 27 is also y, so that's a good start. Adjacent to 27 is a little more complicated. It's this and this, right? We'd have to go the whole distance from point D to point B in the picture. So that's going to be 400 plus x. So let's write that down. The tangent of 27 degrees is y over 400 plus x. Okay, 2 equations, 2 unknowns. We can solve the system. So we're trying to solve for y. So we should probably try to get rid of x. So what I'm thinking is I'm going to start with this and say that, is that an arrow? I mean, that's what I'm going for. Okay, here. X is equal to, what is x equal to? So if I bring the x over, I get x tan of 53 equals y. So x is equal to y divided by the tan of 53. Why am I writing a 2? Tan of 53. Okay, that's one thing. Now over here, I'm just going to cross multiply and say that 400 plus x times the tan of 27 is equal to y. Okay, so I'm going to continue working on this part because it's a little easier than like substituting and then solving. So let's see if that makes any sense when we do it. So 400, just distributing, tangent of 27 plus x tangent of 27 equals y. All right, so we actually know that this this x here, this x right here, is the same as this x. It actually has a y in it. So I'm going to continue working on what I'm working with now, and I'm going to move that to the other side. So I'm going to say that nope, 410. I confused myself, that t looked like a plus. Tangent of 27 equals y minus x tangent of 27. Okay, and I still know that this x is the same as all the others, so it's actually y over the tangent of 53. Good, because now I'm going to actually substitute. So 400 tangent of 27 degrees equals y minus, so I'll say y over the tangent of 53 times the tangent of 27. Okay, so what can I do here? I can actually take a y out of both things on the right-hand side. So let's do that. So 400 tangent of 27 is equal, let's take the y out and then do 1 minus, this is the tangent of 27 over the tangent of 53. So what you would never want to do on this is you would never want to grab a calculator at all, really. You would just want to keep using the tangent of 27, 400 times the tangent of 27, tangent of 27 divided by the tangent of 53. Life is just easier when you use these exact values. As soon as you grab a calculator, you're getting approximations, and it just gets worse, basically. So here, I actually know that y equals, so it's 400 tangent 27 divided by 1 minus the tangent of 27 over the tangent of 53, which you could like potentially leave as your final answer. I think it's a little messy. So what I'm going to do is in the denominator, I'm going to get a common denominator. So in the denominator, I'm getting a common denominator. So, and it would be tangent of 53, right? So I'll get the tangent of, oh, look at that. Somehow I created like an ellipse. I'll get the tangent of 53 minus the tangent of 27 all over the tangent of 53. Okay. And then my last step here for what I'm going to say y is equal to, I'm going to simplify the complex fraction and get 400 tangent of 27. So that's the original numerator. And then tangent of 53. So this tangent of 53 is this tangent of 53 right here. Right, because it's the denominator of the denominator flips up to the numerator. And then over tangent of 53 minus tangent of 27. This is the exact answer. That's the exact value. Now, what I don't know is what the approximation is. So I'm actually going to use a calculator to give me that. But what I'm going to do is I'm going to do two things on the calculator. So let's switch to the calculator. Hope this works. Hope it doesn't mess up. You never know. Okay, so I'm going to start a new problem. So I'm going to press doc 4 and then option 1. So that it just like cleans everything out. Calculator, you can see it says 2.1. Over here is 1.1 with all that stuff. Back to 2.1. The var key is empty, probably empty in both of them. But if it wasn't empty in both of them, you would be able to like just have variables for problem 1, just have variables for problem 2. You could redefine a in both of them, whatever you want to do. So let me first just see what the calculator says. 410, 27, 10, 53 over 10, 53 minus 10, 27 decimal. Okay, 330.836. So let me write that down. 330.836. It's probably in feet, I would assume. Yeah, she moves back feet, so that's got to be feet. Okay, good enough. Let's see what the calculator does if I ask it to solve this. So let's give it the whole system. Let's do menu 3, option 7 for system of equations. And then there's 2 equations. Our unknowns are x and y. All right, the first equation is that the tangent of 53 is equal to y over x. The second equation is that the tangent of 27 is equal to y over 400 plus x. And I'm going to hit Control Enter. And I get that y is 330.836, which is good. This also tells us what x is, which we never solved for because we didn't need it. We just need to know the height of the thing. That is the inaccessible distance. That's in your picture. If you're looking at it, that's x. Obviously, it's x. It says it. That's the distance AB in the picture. Let's see what it says the exact answer is. So it gives like kind of a weird version of the answer and uses things that we don't necessarily know yet. So I don't really want to talk about it, but this is equivalent. It just looks weird. And what we're going to do is we're going to learn very soon how to show that this is equivalent to what we got. But for now, we're just going to accept the decimals. So these are the decimals. They're definitely the same. So I'm going to go back to the notes. And so you can take a look at them one more time and then call it quits on this video, come back to the next one, maybe do some more stuff. So this is a very cool problem. I recommend that you try to solve it a couple of times, right? Like go through it a couple of times. You'll get kind of like the steps down. And once you have the steps down, it's like very procedural, but it's neat. Indirect measurements always pretty much work out this way with like a system of equations of some sort. So it's a useful skill to have. And it's pretty neat. It's a very neat application. So I will see you in the next video, and I hope you're finding these helpful.